Okay, I've got a friend with a XX250 he uses for karting, and he gave me these pipe specs that he wants me to analyze. So this video is going to be about that, analyzing a pipe. Well, in combination with the engine. So he gave me all the specs, but he didn't give me the header length, and he didn't give me the exhaust gas temperature. So with this end of power band RPM, these two numbers have to match. So I'm just using the suggested temperature, EGT, and I changed the header length so that this number matches this number, which is usually pretty true when the to match the end of power band RPM. So on sheet 4 I entered all the info, and I just need to click calculate to see how the transfers are, and I expect them all to be 100%. Yep, because an X250 has very maximized porting. So on sheet 2 we're going to enter the details for his diffuser and his baffle, except I overlooked something on sheet 1. I'm just now going over the details. This is not correct, and this is not correct. And this is not correct. I was looking at two different sheets. Now I'm on the right track. I was confusing his two different pipes. Okay, so on sheet 2 he says the first cone of a 3-cone diffuser is 5.7 degrees. First I need to select this, deselect automatic, and select manual. Okay, second cone at 12.2 degrees. Third cone at 17 degrees. Beginning of second cone, the inner diameter 65. Third cone of 96. And let's double check by looking at the lengths. The end of the length of this one should be the same diameter as what he said right here. And his specs were a little bit, this program only deals in every 10 millimeter segments. So when someone gives me a diffuser to analyze that's not segmented in that way, I have to fiddle and fudge it a little bit to make it match. So the second cone on his is 145 millimeters. So I'm change that to make it 150. And his third cone is 147 millimeters, so I'm making that 150. And I'm compensating on the header to make up the slight difference there. So for 100 millimeters on the first cone, you can't see it, it's off screen, but that is let me see if I can move this. It's right here, 75 millimeters. And he's saying it's 65, which is not right. So I'm going to just say that his angles are off. Well, I'm going to have to change them a little bit anyway to match my adjusted length. So with a beginning diameter of 55 and an end diameter of 65, I can just use this right here, this calculator right here. Which tells me the angle is 2.9, which I will put in here. Second cone of 150. begins at 65 and ends at 96. That's 5.9. It could be that he was giving me the full angle instead of the from centerline angle. That's a good thing to always double check. So this will be probably about half that, which will be 8.5. Let's just enter here. Beginning of 96. Ending at 140. 8.3, yep. He was giving me the inclusive angles. Okay. Okay, so I'm going to put, since this is 100 millimeter, that's 10 numbers, these first 10 right here. Okay, second cone is 150, so it'll be the first 15 numbers. Whoops, that is, I'm already at 15, okay. Okay, and the last cone is 150, so that's 15 numbers starting here. Oh yeah, okay. What I did wrong is I'm exceeding that, so I need to continue on the next column. Where was I at? 20, the first 27. Okay, so that's the second 27 goes right here. And if I did that right, that should all add up to 400 millimeters. So this first section right here is 360, which I know because this right here gives me the length right here. That's 360, and then 40. Those two added together is 400. That's correct. Okay. Okay, so that's ready to go. What did I just do? Okay, let's scroll down and do the baffle. He's got a 2-cone baffle, and again I'm gonna doubt his angles. Wait. Yeah, that's right. 130 length in the first cone. Beginning diameter 140, end diameter 99. That gives me an angle of 9. So 9 goes right here. Second cone 170 long, 99 beginning, 26 end for 12.1. The beginning of the second one is the end of the first one, and the end of the first one is at 130, which is right here, which is 98.8. So I'll put that here. And all I got to do is enter the numbers. Let me see if I can get this where I want it. Let me show you. Okay. That's 130, as you can see right here by the lengths here. That's 130. Okay, we'll start on the second one. And if you're entering a cone that's longer than this length right here, 150, you just leave the two data points blank, and this section right here will be a continuation of this section. But in this case, it's not, and I'm going to make use of these numbers here. His goes 2 millimeters over that section, so I'm going to make sure that those two are blank and trust that these are a continuation of that. So I'll continue 65 and 74. And that's the total length of 300, which is correct. Okay. So now all we have to do is go to sheet 3. And enter the estimated maximum horsepower, which his is pretty high. I'll just put 65. Hold on. Okay. 65. That cell was blocked. I had to unleash it, make it acceptable to accept new data. Okay, with that entered, I'm just going to click autograph, and this is the graph that it gives me. Whoops, lost it again. We've got a big dip of power right in the middle. I would like to look at it at 9,000, but on sheet 3, if you look at any number other than the specified ones here, it won't include the secondary waves. Right there you can see one of the secondary waves. So this has to be kept as Y, and we'll look at 8750. See if we can get an inkling as to why that is dipping down there. Well, this secondary wave has lost diffuser strength right here. It's gained some strength right here. But that's not real bad, so I'm going to look on sheet 1 at the charts here. See if I can figure out why it's losing strength there. This orange zone is this is beginning of the exhaust pulse, and this is the end of the exhaust pulse. So this is, that 0 is exhaust port opening, and then the time goes on. So what I'm looking for is a negative diffuser wave, one of the D waves, crossing its middle, crossing the center of the exhaust pulse to suppress its peak, which I find happens right here, which would be 8750. Okay, so that explains that. So let's see what would happen if wait. I'm going to go back to sheet 3. I'm going to take note of the power. I'm going to cause these horsepower numbers to be entered right here. I'm going to store it in row 1. Okay, and go to sheet 1 and see if there's a way we can make it better. I'm going to do that by letting it calculate. And now I'm going to look at those graphs again and see how it's different. In this case, we've got a crossing right around 7750, and we've also got one about 9250. Let's see how it looks on the higher graph. Okay, it's a little bit better right here. I really dislike how that dips down there around 9500. Sometimes it's just unavoidable, and it has to do with the porting and the RPM chosen. And when you reach a situation like that where you just can't find an easy solution, you have to change the peak RPM or change the porting.